In this video, we will continue to explore the properties of similarity, and usually it will be triangle similarity. So we are given that triangle DEF is similar to triangle HGF. Use vertical angles to label one more angle measure. So because these are vertical angles, we know that this will be 61. So we know that the measure of angle DEF, we know that triangle DEF is similar to triangle HGF. So angle E is going to be congruent to angle G. So we know that angle E is 54, so we will label its partner angle with a 54. So we know that this is also angle 54 degrees. The sum of all three angles in any triangle is 180 degrees. So using this information, if I do 180 degrees minus 54 and 61, that's 65. So that tells me that the missing angle is 65 here and here. Okay, we are given that triangle DEF is similar to triangle HGF. So, therefore, we know that EF, which is right here, will correspond to GF. Use the order of the letters. Don't trust the picture. Alright, we got it. Use your answer above to help you fill in the boxes in this proportion. Then solve for x. Okay, so EF corresponds to GF. So I hear you saying that since EF corresponds to GF and what else? ED. Alright, see the ED is right there and that corresponds to HG. Let me change colors though. So ED corresponds to HG. So these are all corresponding. So if I make fractions out of these, then x over 32 x over 32 will equal 27 over 36. And then we can solve this thing. So x over 32 equals 27 over 36. What's going on with that? 27 over 36. Boom! 3/4. So that's 3/4. Let's cross multiply. So we have 4x equals 32 times 3 96. And then we have to divide both sides by 4. And that's 24. So x is equal to 24. Well, we are given that triangle LMN, shown here, is similar to triangle PQR, shown here. Not congruent, only similar. Silly Susie made a mistake. She started by writing 5x plus 24 is equal to 48. What is her mistake? Well, these triangles are similar, not congruent. So these sides will be proportional, not congruent. So the triangles are not congruent, so the corresponding sides will not be congruent. However, they are proportional. So 5x plus 24 over 48, shown here, should equal another pair of corresponding sides, boom, boom. So that should equal 63 over 56. Let's reduce those. So 63 over 56. That's 9 over 8. So I have 5x plus 24 over 48 is equal to 9 over 8. Time to cross multiply. Yay! Okay, if I multiply those, so I'm doing 8 times 5x plus 24, and then I'm multiplying these, so I'm doing 9 times 48. $432. Interesting. Distributive property. So this will be 40x plus, 8 times 24. I just don't know. 192. Of course, we have to subtract 192 from both sides. $240. And then I have to divide both sides by 40. So that's going to be 6. So x is equal to 6. For problem number 10, I've started a picture for you. Now keep in mind that triangle PQR is similar to triangle STU. So here's PQR, so this must be STU. I'm making sure that the corresponding angles are congruent as marked. Okay, label the side lengths that were given to you. So PQ is 24. So let's go ahead and label the 24. QR is 30. So there you go. ST is 20. Interesting. And SU is 28. Put an X on side TU. Boom! Set up and solve a proportion to find the length of side TU. Okay. Well, looking at corresponding sides, so I know that TU corresponds with 30. So I could do X over 30, for example. I need another pair of corresponding sides. Okay, I could do 20 and 24. So following the same pattern, X over 30 equals 20 over 24. Both of these are divisible by 4. So that's going to be 5 over 6. And then it's time to cross multiply. So I will get 6x is equal to 150. And of course, if I divide both sides by 6, what am I going to get now? $25. Okay, and that's the answer to the length of side TU. For number 11, Rhonda Rongo made a mistake. She set up this proportion. Explain why this is incorrect. Well, she used 16 over 36. Okay, she's doing this over this. So it looks like she's about to use the side splitter theorem, because 16 is definitely not a side of a triangle. It's just a portion of a side. So side splitter theorem. But then she did x over 27. You can't use the side splitter theorem when you're dealing with these parallel sides. The side splitter theorem is for these sides over here. If I was going to somehow do TV over TU, then that would work, but not the x and the 27. The thing is, when you're dealing with the parallel sides, you need to look at the small triangle and the big triangle separately and do new over old equals new over old. So let me show you what I mean down here. So this is the small triangle that's right up here, and this is the large triangle that represents the entire shape. Okay, so US is 36, and we've got the 27, that's ST. All right, and WV, now I'm looking at the big triangle, WV is X. Okay, now, is 16 the length of UW? No, it's just SW. The length of UW is going to be the sum of both of these. So that's going to be what, 52? So I'm going to treat this triangle as new, and I'll treat this triangle as old. It really doesn't matter just which one you pick to be new and which one you pick to be old. But we do new over old equals new over old. So we will do x over 27. All right, notice that's the same thing she had so far. But then, for the other pair of corresponding sides, it should be 52 over 36. Okay, not 16 over 36. So I'm just going to reduce this fraction. So we have 52 over 36. That's 13 over 9. So I have x over 27 is equal to 13 over 9. So if I cross multiply, that's going to give me 9x equals, okay, and if I cross multiply over here, that's 351. And then I need to divide both sides by 9. So that's 39. All right, so that is it for problem number 11. All right, for number 12, part A, we're supposed to explain with words and numbers how you can tell that these triangles are similar to each other. Well, so we know they are similar because we are being told they're similar. The only way that's going to happen is if the corresponding sides are proportional. So I'm going to go ahead and write down those words. They are similar because the corresponding sides are proportional. Whoops, too many P's. And of course, the angles are congruent. Since they're both rectangles, the angles are all 90 degrees, so the angles are congruent. All right, so I need to mention that too. And the angles are congruent. Okay, that's going off the screen a little bit. Okay, now for the numbers. So now we're going to go ahead and prove that the corresponding sides are proportional by doing new over old equals new over old. All right, that's really what proportional means. So for example, we can do, you know what, normally, for some reason, I like to make the bigger triangle, the bigger shape new and the smaller shape old, but I'm not going to do that this time. So I'm going to call this new and this old, so I can just do the fractions in the order that they appear. So now I will have 6 over 8, and that must equal 9 over 12. 6 over 8 equals 9 over 12. And because this reduces down to 3 over 4, and both of these are divisible by 3, and this reduces down to 3 over 4. Okay, so we've just proven that new over old equals new over old. So these numbers show that the corresponding sides are proportional. Okay, now, similarly, we're supposed to explain why these rectangles are not similar. So I'm going to do the same type of thing. So since they're not similar, and we already know that the angles are congruent, the problem must be that the sides are not proportional. Okay, so I'm just going to write that down. The corresponding sides are not proportional. Okay, in other words, new over old does not equal new over old this time. So again, I'm going to call this new, and I'm going to call this old. So if I do these corresponding sides, that's 3 over 8. And then if I do these corresponding sides, that's going to be 5 over 12. Neither one of these reduce, so we can immediately see that 3 over 8 does not equal 5 over 12. So numerically, that proves that these sides are not proportional. All right, number 13 is the last problem. Oliver Oopsie made a mistake. He started by writing 3x plus 14 equals 8x plus 4. Explain why this is incorrect. Well, we are given that UV is a mid-segment. And the key property of a mid-segment, this line that's parallel and connects midpoints, the key property is that the mid-segment is half the length of the parallel side. So these are not congruent. These lengths are not equal. The real deal is if I double the length of the midsegment, all right, if I did 2 times 3x plus 14, then that should equal the other side, 8x plus 4. All right, so they're not just simply equal. All right, so here I've gone ahead and written out that sentence. Since segment UV is a mid-segment it is half the length of the parallel side. Okay, so now we can go ahead and solve for x. A little distributive property here gives us 6x plus 28 is equal to 8x plus 4. I feel like subtracting 6x from both sides this time, keeping it positive, so that'll be 2x plus 4. If I then subtract 4 from both sides, that's going to give me 24 is equal to 2x. And of course, then I would divide both sides by 2, and that will give me x is equal to 12. Okay, check your answer by plugging in your x. Okay, so if I plug in this x, I should find that uv is half the length of ts. So let's do that. Okay, so segment uv, well, the distance, the length of uv is 3x plus 14. If x is 12, then that's 3 times 12 plus 14. Okay, and that is 50. And then the length of TS is 8x plus 4. So if x is 12, then that makes 8 times 12 plus 4. And that's 100. So, just like we thought, UV is half the length of TS. So again, I've just written it down. We know the answer is correct because UV is half the length of TS as it should be. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.